Okay, so some great questions here. I figured it'd just be easier to go through these guys as a video rather than to answer them all by text, one by one by one. To start off with the first two. So here we have back to our comparative statics. Hey, something happens to our market, which curve ends up moving in which direction. So to start off, what we're looking at is we're looking at the market for donuts. Market for, and I'm just going to abbreviate that as D for donuts. What do we have in the market for donuts? All of a sudden, the price of muffins suddenly increases. Okay. Note, donuts and muffins are substitutes of production. Okay, so that word there, production, that is our big hint as to what we are looking at by saying they are substitutes of production. That means we are talking about our supply curve. So, hey, I know just from that, if price of muffins goes up, my law of supply, quantity supplied of muffins will also be going up. Okay, so that's what's happening in the market for muffins. But we're not interested in the market for muffins. We're trying to analyze the market for donuts. So what's happening in the market for donuts? Ceteris paribus. That is, everything in this market for donuts is fixed except for this impact from the market for muffins. That is, if we take a look at this, what do we end up having? So let's take a look at price, quantity. We'll get our demand curve downward sloping. We'll get our supply curve upward sloping. So supply and demand. And keep in mind that with this, what we have is initially, let's use the right tool here. Initially, we just have a fixed price, right? Just that equilibrium price for donuts, right? This is the market. That is the market for donuts. Okay, so price of donuts is fixed. Well, what ends up happening? Well, we have this shock over in our market for muffins. Well, altogether, hey, if muffins and donuts are substitutes of production, if I'm putting more of my time, more of my resources, or more of my labor into producing muffins, that means I don't have as much to produce donuts. So that means that my quantity supplied of donuts must be going down. Keep in mind, all of this, nothing's happened to the price for donuts yet. So this is strictly just a reaction due to a change in the price of muffins and to the fact that I'm producing more muffins. Keep in mind, our production possibility frontier is set up to represent substitutes, so donuts, muffins, and we can just pretend it's a linear production possibility frontier. Doesn't have to be. If I started off producing something like this, and all of a sudden, due to this increase in the price of muffins, I'm now making more muffins. Well, by making more muffins, that means that I must be having fewer donuts, right? So flows through in that kind of logic. More muffins, substituting fewer donuts. How does that work out over here? Well, keep in mind, we're talking about the production. And by making more muffins, I'm able to produce fewer donuts. So in that production side, my supply is shifting to the left. As my supply shifts to the left, what does that end up doing? Well, what I end up obtaining is this disequilibrium. Supply shifts to the left, causing this disequilibrium. What used to be my quantity exchange is now just my quantity demanded. And then I have the new quantity supplied all the way down there. So disequilibrium, all of these people want donuts, but given this change in relative prices, you don't want to produce as many donuts anymore. So we have a problem. Our demanders begin to bid up the price, saying, no, we'll pay more for donuts if you make them. Please, we really want donuts. So they push up the price. As they push up the price, you start to say, yeah, okay, sure, I'll start to make more donuts. And so we move up along the supply, along the demand, back to our new equilibrium. And we would have our new equilibrium price and quantity. So there's P1. Keep in mind, if we want to compare the quantity demanded, that was the original, we'll call that Q0 and Q1. So what did we witness? We witnessed prices of donuts rising and total quantity exchanged of donuts falling. So supply shifted to the left, price went up, quantity went down. Okay, next question, very similar. In this case here, we're talking about complements and complements of production. So in this case here, we are looking at the market for whole beans. So market for beans. I'll just abbreviate that, shorten it a bit. And what do we have here? We have the price of corn. Okay, price of corn is again going up. Note, beans and corn are complements of production. So, okay, to start off, production, that's my key there, that this is going to be with respect to quantity supplied. So, hey, price of corn up, quantity supplied of corn up. In this case here, we're looking at complements. That is not our traditional production possibilities, but rather in this case, hey, as I produce more corn, I'm also able to produce more beans. So just simply by making more corn, a spin-off of that is that my beans grow more, right? This is because you actually end up planting corn and beans together. They have this symbiotic relationship. They support each other. The more corn you grow, well, by default, the more beans you get as well, if you just wanted the background behind that story. Keep in mind, all this happened for nothing happening to the price of beans, right? It was just simply this change in relative prices affecting this quantity, which then filtered through to affect our bean market. So how is that working out? Well, let's visualize it. Price, quantity. We have our demand. All right, think about what market we're talking about. This is our market for beans. So I have my demand for beans and I have my supply of beans. Equilibrium, well, we get our original price, or original quantity, or original price, Q0, P0. And then what did we say happened? We said, hey, for this fixed price over in the bean market, my quantity supplied increased, right? And don't get lost by this up arrow. That's not an up arrow here. That is increase, that is more quantity supplied to the right. So more quantity supplied, a movement to the right, brings me somewhere over there. That is, hey, at my original price, I now have all this excess supply. This Q0 is now my quantity demanded. That bit there, that's now my quantity supplied. That is due to this producing more corn. Oh, I have all these extra beans, more beans than I can sell at the current price. I'd rather sell them than let them rot, so I put them on sale, I put them on clearance. The price of beans begins to fall. As the price of beans begins to fall, people begin to demand more, and we work our way back to equilibrium, and we obtain our new quantity. Let's use the right tool. We get our new quantity, there we go, finally, and new price. So price 1, quantity 1. So what happened in this case to summarize? Well, to summarize, because complements of production are supply increased, that is supply shifted to the right, this caused our price to fall and our quantity exchanged to rise. So the outcome of that. Supply shifted to the right, price went down, quantity went up. Okay, let's see what else we have here. Finding a black market price and a quota. So first off, the big thing with both of these is they're actually really the same question. And I say that they're clearly not, but the process is actually identical for both of them. So let's take a look at that here. We have our price, we have our quantity. And then what we have, let's just take a look at the first guy here, because we can then work this out for the quota as well. We're saying that we have the following. We have price of, what's our demand, or sorry, what's our supply here? 5 plus 4Q. And then we have our other one, price equals, and we had 93 minus 3Q. These are just the equations that you gave to me in the email, of course. So then we're saying, well, let's start off just by drawing our supply and our demand. So let's start off with our demand here, and demand starting at 93, dropping at a rate of 3. We'll say something like that. That's my demand curve, and again, 93 being my intercept. The other one then, there's my supply, 5 plus 4Q, so we'll say 5 somewhere around here, and 4 is a little bit steeper, so we'll try to at least make our curve somewhat correct in our slopes. Okay, what we have initially to start off is we would have our equilibrium price and our equilibrium quantity exchanged. But of course, we're not asking for equilibrium, so we can almost just kind of ignore these for the time being. What we are interested in, though, is the price ceiling. So what we want to do is we want to put in a price ceiling, and we want to put in a price ceiling of 13. So I'm just going to presume something around here, something around there. That would be my price ceiling, and at a price of 13. Okay. What we would then have at this price ceiling, we would obtain a 13 to our supply curve would give me my quantity supplied. 13 to my demand curve would give me my quantity demanded. So quantity supplied, quantity demanded. Keep in mind, it's the lesser of these two that becomes our quantity exchanged. So thus, my quantity supplied becomes my quantity exchanged. From here, I need to figure out what my black market price is, and that is if quantity supplied exists, all the way up to the demand curve, right? All the way up to what these suckers are willing to pay for this good is what we would end up charging for our black market price. So all the way up here, this would be my price, black market. So let's go see how we can actually work this out and see what our values work out to. And hey, maybe there's, given how close you were, well, in terms of 1, maybe we'll see. Maybe there's an error in the answer key. Typically not in these cases, though. So let's take a look. First thing we need to do, we need to figure out what is this quantity supplied, right, for this quantity exchanged. And how exactly are we going to get this? Well, to get that, we're going to take our price ceiling and we're going to put it into the supply curve. By putting 13 in for the price to our supply, we can get correspondingly our quantity supplied. So let's identify our supply here. There's our supply curve, and we want a price of 13. So we'll go 13 equals 5 plus 4Q. Now we just need to go play a bit of an algebra game, rearrange some stuff to figure out what exactly that works out to. And so let's go through that. To start off, let's do 13 minus 5. So 13 minus 5 gives us 8, and that equals then 4Q on the right side. Now, get Q by itself, so 8 divided by 4. Well, 8 divided by 4, that yields for us 2. And we get 2 as our quantity exchanged. From here now, we want to figure out what our black market price is. So to figure out our black market price, we take this 2 all the way up to our demand curve. And as we bring it all the way up to our demand curve, we will get the corresponding black market price. So in this case here, we want to utilize our demand at a quantity of 2. So we would have price equals 93 minus 3Q, where Q is 2. So in this case here, we have 93 minus 6. 93 minus 6 yields for us a price of 87. So we get our black market price of 87. So that's how we could work through this question in terms of a black market, right? Price ceiling, holding down our quantity supplied. We have all this excess demand for sure. And as a result, we get this, potentially, we get this higher black market price. Okay, the next question then is, well, what if we have a quota, right? And here you say the government imposed a quota of 1, but any number, how do we figure out this market price? Well, let's take a look at that. Let me just clean up this diagram a little bit. Let's get rid of this price ceiling here because we're not dealing with that anymore. Okay, so we have our initial supply and our demand. Maybe I can clean that guy there up. There we go. So we have our initial supply and our demand. In this case here, let's suppose that we impose a quota, and hey, just because we already worked it out, let's say we impose a quota of 2 units, right? And yeah, okay, your question is 1, but let's use 2. Well, we impose a quota of 2 units, so we'll say somewhere about here. And that is, in this case here, either the government has allowed this to happen, the government has imposed it, or the firms themselves, they've got together and they've imposed this quota on themselves. In this case, essentially by the quota, they have willfully held their production lower than what we would have witnessed at our allocatively efficient equilibrium. By holding this lower, well, what we end up getting is, well, what price should we charge for this new lower quantity? Well, we could go and we could charge our lowest price that we would be willing to accept, right? We could do that. Lowest willingness to accept. But we could charge more too. We could charge the market price for it. Yeah, sure we could. But what we could also charge is we could charge all the way up to the demand curve there. Let's actually get that a straight line. We could charge all the way up to the demand curve, and we could charge what these suckers are willing to pay for this good. So by going all the way up to our demand, our maximum willingness to pay, we can obtain from this our corresponding price underneath the quota. And that is our price underneath the quota when our quantity is 2. Hey, quantity 2, our corresponding price is 87. And so hopefully with that, you see why I was saying that, hey, a price ceiling with a black market and a quota, they're almost the exact same question. We get the same numbers in the end. The theory, the idea behind them, of course, are different as to what's causing them, but mathematically they work out the same. We get some quantity exchanged and we go all the way up to this demand curve to get our corresponding price. So hopefully that helps with those first 2 that you have. Next one, well, let's take a look at this. We have a market being served by a monopolist. So let's take a look at this monopolist market. So keep in mind what's happening with this. Let's draw the diagram. And again, it doesn't hurt, right? And I always recommend this, especially for tests. Get out of the computer, right? Have a piece of paper beside you, draw stuff out. Get your mind out of the computer. It's so easy when we're doing computer-based stuff just to have everything digital. Bring it onto a paper, draw a quick diagram. You have plenty of time. It should be fine just to quickly hash this out. What do we have for our curves? To start off, we have our supply curve, which is price equals 10 plus 5Q. And we have our demand curve, which is price equals 98 minus Q. So drawing that demand first, let's say 98 somewhere like that, and minus Q. So we would have 98, which technically gives us 98 there as well. On the other side, well, here, let's finish labeling this. This, of course, is our demand. We will be getting to a monopolist, so this is also my average revenue or my price. From the supply side, I'm starting at 10, and I have a slope of 5Q. So starting at 10, and quite a bit steeper, something like that. That is my supply. Keep in mind, this is also the marginal cost of the firm. So again, the way we'd want to think about that. Okay, we want to figure out ultimately what is the price of the good in this market if it was serviced by a monopolist. And right, typically what we would do is we would say, okay, supply equals demand. Oh, let's use a line tool here. Supply equals demand. Boom, there's our market price. Boom, there's our market quantity. But technically our supply and our demand curves, they make the assumption of perfect competition, right? That equilibrium there, that is the perfectly competitive equilibrium. If we have a monopolist servicing this market, well then, we don't have this. We have actually a higher price and a lower quantity. And the way we get that is we need to derive what the marginal revenue curve is, right? And so for our marginal revenue, what we're going to have is a price equals and then some line, right? Keep in mind, if we wanted to label all of this, this was my demand, this was my supply. So what we need to recall is the relationship for any firm with market power, so monopolist included, the relationship between our demand and our marginal revenue. And that relationship was that our marginal revenue curve had 2 times the slope of our demand curve. So in this case here, our demand curve was 98 minus 1Q. So our marginal revenue, that would be 98 minus 2Q. Right? Technically, there is a 1 in front of that Q. So 1 times 2 is 2, and we have our new marginal revenue. So to bring that guy in, we would have, starting at 98, twice as steep. Where does that bring me? Somewhere around here, perhaps? Right? If this is twice as steep, hey, if that guy's 98, half of that would be 49. Again, just if we wanted the reference points. Now from here, we can say, okay, this was my marginal revenue. Now we have the tools we need to calculate our Q star, the quantity exchanged in this market, and the corresponding price. So how do we go about that? Well, Q star is where marginal revenue equals marginal cost. So marginal revenue equals marginal cost occurs right where the green and the red lines intersect each other. So dragging that point down, we get our corresponding Q star. So let's solve for that first. Green and red lines equal to each other. So green and red, we would have 10 plus 5Q equals 98 minus 2Q. Let's get rid of this negative first, so let's add 2 to both sides. 10 plus 7Q equals 98. Let's bring this 10 over. So I have 7Q equals 88. And then finally, to get Q by itself, we're going to divide both sides by 7. So dividing both sides by 7, we get 88 divided by 7 gives me Q of, we'll carry around a few extra decimal places here, 12.5714. Right, and in this case here, we're D2L, so we're recording to 2 decimal places typically. I'm not looking for quantity, I'm looking for price. So, hey, this is an intermediate step. I'm going to carry around an extra 2 decimal places just to ensure a bit of accuracy. Okay, how do I get my final result? How do I get my final answer? Well, from here, quantity, I need to get the actual price that I sell things at. And again, what I'm going to do is I'm willfully holding low my quantity, just like we did with our quota. And by holding low my quantity, I'm going to go all the way up to my demand curve. That is the maximum willingness to pay, what the suckers are willing to pay for 12.57 goods. And in that sense there, I'm going to get my price. So again, just like with our quota or our black market, we're going to take our quantity, we're going to put this into our demand function to get the corresponding price. So price equals 98 minus 12.5714, and 98 minus 12.5714, that gives for us a price of 85.43. Right, and technically, right, that was 85.4286, but rounding it to 2 decimal places, 85.43. Okay, so that's how we work out our equilibrium quantity exchanged and price in the case of a firm with market power. In this case, yes, we said monopolist, but the same could be truthfully done for an oligopolist facing this kind of market structure or a monopolistically competitive firm. Any firm with market power, marginal revenue twice as steep as the demand curve. Okay, last question to be taking a look at here. What is the total benefit received when 3 units are consumed? So, okay, we have a bit of a different equation going on here. Price of 140 minus Q and price of 6 plus 8Q. And again, let's visualize this, right? This way here we can kind of get out of the math. We can get a picture to represent what's going on. It's a bit easier to not get lost. So starting off 140 minus Q. Oh, let's use a line. There we go. There's my demand. That's 140. 140 divided by my slope is just 140 over 1, so I get 140 there. And then for my supply, what do I have for my supply? Starting at 6, so somewhere down here. And significantly steeper, so we can go something like that. That guy there, that's my supply curve. And again, starting at 6. Okay, we want to know what is the total benefit. So total benefit when Q equals 3. So when we're consuming 3 units, what is the total benefit that we receive? Well, let's keep in mind that my demand curve is also my marginal benefit. That is the extra benefit I receive from an extra unit. And of course, we have this diminishing marginal benefit. The more of this I consume, the less extra satisfaction I get from the extra unit consumed. So let's presume that 3 is something like so. And what we need to work out is, okay, if this guy here is 3, what is the corresponding price? That is my maximum willingness to pay, or the marginal benefit that I received from that third unit. So to get so, I need to go to my demand, right? 3 up to my demand. So price, marginal benefit, maximum willingness to pay equals 140 minus, and Q is 3. So that is, I'll get a price of 137. Okay, I want to know what my total benefit is. How do I work that out? Well, my total benefit is the aggregation underneath this marginal benefit curve. So that is, my total benefit is going to be this whole shaded area here. This all together would be my total benefit. So, hey, we see this is a bit of a funny geometric shape here, but we can actually work it out quite easily because it's just a triangle and a rectangle. So starting off with that rectangle, that's just base times height. So in this case here, I have a base of 3 times a height of 137. So 3 times 137 gives me 411. Next, little triangle there. There we go, something like that. Well, again, it has a base of 3, so area of a triangle is 1/2. 3 times a height, well, in this case here, I also have a height of 3. So 1/2 base times height, so 9, 3 and 3 is 9. Half of 9 is going to be 4.5. So 411 plus 4.5, that gives me a total benefit of 415.50. And thus we have our total benefit. Okay. Oops. I just looked at the email. Question that I actually had. A little bit of a math error in transcribing this over. The actual question was not 140 minus Q. It was 140 minus 10Q. So we'd get a little bit of a different answer, but the process would be the same, right? So keep that in mind. This isn't the answer to the question you sent me, but you do the exact same process. We just have a little bit of a different demand curve here, right? Instead of going 140 to 140, it'd be going 140 to 14. We'd have a different price there, same quantity. So we just have different heights for these two guys here. So we get different results in that way, but you do the exact same process there. Okay, let's go jump over to the next email I have and take a look at the next set of questions that I've received. So the next one is talking about external costs. So over into our kind of pollution externality time. And our formulas in this case are price of 6 plus 2Q and price of 95 minus 4Q. Okay, what else do we know? We know that for every unit produced, society faces an extra cost of $3 per unit, right? So extra cost for an extra unit, that is my marginal external cost, which is $3 per unit. Now, what am I actually interested in? I'm interested in what is the total external cost that society faces from this production. So I want to know, hey, what is my total external cost? Okay, well, let's visualize this to start off. We have our price, we have our quantity, downward sloping, I have my demand, so my demand curve there, 95 minus 4Q. So there's 95, this is my demand, or to think about it in this way here, my marginal social benefit, which is also my marginal private benefit. Upward sloping, I have 6 plus 2Q, so starting at 6, not as steep, a little bit shallower. I have my supply curve, which in this case here is my marginal private cost. And that is starting at 6. In this scenario here, I have a marginal external cost. That's why I know this is just private cost and not also my marginal social cost, because my marginal social cost equals my marginal private cost plus a marginal external cost. So that is, I can figure out what this guy is. Marginal social cost equals marginal private cost. So this guy, 95, oh, sorry, no, not that guy. Marginal social cost equals marginal private cost. This guy, 6 plus 2Q. So 6 plus 2Q plus my marginal external cost, that guy, so 3. So what do I have here? Marginal private cost plus marginal external cost. So my marginal social cost then is 6 plus 3, that's 9 plus 2Q. So if I want to visualize that, hey, there's 6. Let's say that's 9. Same slope, 2Q, 2Q, so they're parallel lines, and I get my marginal social cost curve. Okay, what are we looking for? We're looking for that total external cost. Well, this total external cost is at the private optimal, right? We only have a total external cost at the private optimal. At the social optimal, it's been accounted for. So what we're looking for is our total quantity when my marginal private benefit equals my marginal private cost. Private optimal, we'll call that QP. So to solve for that, let's just set equal supply and demand, or marginal private cost, marginal private benefit. And we have 6 plus 2Q equals 95 minus 4Q. Let's get rid of that 4Q to start off with, so add it to both sides. 6 plus 6Q equals 95. Let's move this 6 on over, so I get 6Q equals 95 minus 6. That's 89. And then get the Q by itself, so divide both sides by 6. And we have a quantity of 14.8333. Right, and again, it's just 3333 repeating. I'm going to again carry around extra decimal places because this is an intermediate step. That is, this isn't my final answer. What I'm looking for is my total external cost. So 14.8333. Now, okay, how do we find this total external cost? Well, let's keep in mind, every extra unit, society faces an extra cost of $3 per unit, and we are producing 14.833333 units. Each of these has an extra cost of this, so the total extra cost is going to be 3 times 14.833333. And we can calculate it just that simply. Of course, where does this actually fit graphically? Well, 14.833333 all the way up to my marginal social cost curve. Keep in mind what is going on. This vertical distance between these two curves here, that is my marginal external cost. That is 3, right? We see that here, 9 to 6, that's 3. So hey, I have this extra cost of $3 per unit all over 14.83333 units. Well, that is this difference between the two all the way up to my quantity private. That area here, that is my total external cost. So I can calculate that as 3 times 14.8333, and that there is $44.50. So based off of that, I have a total external cost of $44.50. Keep in mind, right, the difference between total external cost and total cost. If we wanted to work out total cost, with these questions it gets a little bit tricky. We would need to differentiate between if we want to find out our total social cost versus total private cost, or that is the total cost to society versus the total cost to the private individual. And the reason why I make that distinction, total social cost, total private cost, these guys are again just the aggregation underneath the corresponding marginal cost curve. So that is, if we want to find out the total private cost, well, total private cost would be the aggregation underneath that marginal private cost curve, would be this entire brown area. That would be my total private cost of consumption. My total social cost, however, we'll do red for that. That would be the aggregation underneath my marginal social cost curve. So that would be essentially the green and the brown added together, or this entire area underneath the marginal social cost curve all the way up to our quantity private. So our result in that case there. Again, all our question was asking for was that total external cost, which was the difference between these guys and just the green area. So hopefully that helps a bit in figuring out the difference between all these different total costs when we have an externality. Last question that I have in my inbox for today thus far is going way back to our producer theory. And we have the following for cost curve information. Average revenue of 5, average total cost of 10, and average variable cost of 4. And we're asking the question, we're an analyst and we observe the following information, and we also have with this a Q star of 1,000. What do we expect to witness in this market over time, right, as we transition into the long run? Well, okay, what you have to remember is that kind of signal, what kind of determines what's going to happen between the short run versus the long run, is the response to profit. If we have positive profit, we will witness entry if no barriers. Right, and it doesn't say anything about barriers in this question, so any positive profit, we would expect entry. Any negative profit, and we will expect exit. And again, that is if there's no barriers preventing exit. Sometimes there can be government legislated barriers that prevent exit from the market. So positive profit entry, negative profit exit. Then, as we go through each of those, let's go positive profit, negative profit. Well, what ends up happening? Positive profit, we've said we would have entry. As we have entry, we would have more firms. More firms competing in all this sense would end up pushing down the price. On this side here, we would have exit, meaning we would have fewer firms. And having fewer firms, well, less competition between them, the price begins to rise. So we need to figure out which of these two areas we're in. Well, let's keep in mind our profit equation. Profit is total revenue minus total cost. Okay, well, I don't have those. I just have averages. So, hey, I could work out my average profit. That is, I could divide everything by Q. So average profit would equal average revenue minus average total cost, right? And all I did for that is I just did profit over Q, which is total revenue over Q minus total cost over Q, right? In this case here, now I just have averages for everything. Hey, I have an average revenue. That's 5. I have an average total cost. That's 10. 5 minus 10, that gives me negative 5. I have negative profit. I'm over in this realm. Negative profit means that I'm going to have exiting of firms, right? Firms will be leaving. Fewer firms mean that I would expect the prices to begin to rise. So a little bit going on there. That's the end of what I have really for questions that have come in overnight through to this morning. There are a few questions that came in where people are coming across primarily trade style questions, and a few other ones popping in as well, where they're like, oh my goodness, there's this question, but I don't think an actual question is being asked, or I don't have the diagram, I don't have the context, I'm missing the formula. How do I answer this? Yeah, that's a mistake. When I put together the practice quiz, I just selected all of my questions in my question bank, and I said, yeah, randomly throw questions in for this practice quiz. What that meant is that it also brought in questions from the first and second midterm for the short answer that were dependent on those contextual emails, right? So in that case there, it was like, hey, use the equation in that contextual email, but it doesn't say so in the question. What I've done is I've gone back through that practice quiz. I've removed all of those questions. So if you refresh, you may have to log out and log back into D2L. Those questions shouldn't be showing up any longer. So that was just a mistake in the initial population of the quiz. Hopefully that's gone and you're not running into that problem anymore. If you have any other questions throughout the day, of course, feel free to reach out to me. Otherwise, definitely during office hours when that comes up. Okay, thanks.